Now, the third problem is examine the continuity for different functions are given. See, there are three ways in which the questions will be asked. Sometimes what they will give you is they will give you the function and they will give you the domain. Sometimes they will not give you the domain. So at that time what you are supposed to do is we need to define the domain in the first place and then carry out with the problem. For example, f of x is equal to 3x minus 5. So x belongs to a real number. Now for these kind of problems, how we are supposed to approach is, let c be any value which belongs to the real number system. So let c be any value which belongs to the, I am writing real number system because the domain of this function is real number. It can be any real number. So for any real number, if limit extends to c, f of x is equal to f of c, then the function is said to be continuous. So for this problem what we will do is, limit extends to c, f of x is how much? 3x minus 5. So this will be 3c minus 5. Let this be equation number 1. Now what is f of c? So f of c is also equal to 3c minus 5. Let this be equation number 2. Since limit extends to c, f of x is equal to f of c, we can say that this function is continuous throughout its domain. Second. Similarly, if you look at the next problem, f of x is equal to 1 divided by x minus 5. So this is a rational function, right? A polynomial divided by another polynomial. So here if you look at the domain, you can take the domain in such a way that x is any real number except 5, because when you substitute 5, the denominator becomes 0, right? So that is how the domain is defined. Now what we will do is, let c be any value except 5, because c cannot be 5 as it does not exist in the domain. Again I am doing the same thing. Limit extends to c. What is f of x? F of x is 1 divided by x minus 5. So this is 1 divided by c minus 5. Now what is f of c? F of c is also 1 divided by c minus 5. So since limit extends to c, 1 by x minus 5 is equal to f of c, this function is also a continuous function. Similarly, if you look at the third problem, so third problem is f of x is equal to x square minus 25 divided by x plus 5. So from looking at this function, we can say that the domain is going to be any real number except minus 5, because minus 5 cannot be substituted in the denominator. This is also a rational function, right? Now for this again, let c be any real number except minus 5. Then limit extends to c, x square minus 25 divided by x plus 5 is equal to, what is the value for it? So if you observe here, it is going to be limit, so when you substitute the limit, it is going to be c square minus 25 divided by c plus 5. It is going to be c minus 5 into c plus 5 divided by c plus 5. So c plus 5 will get cancelled, answer will be c minus 5. Similarly, if you try to calculate f of c will also come out as c square minus 25 divided by c plus 5. This value will exist because, see, I have cancelled c plus 5 and c plus 5 only because of the reason c cannot take minus 5. So here also the answer is going to be c minus 5. Since limit extends to c, f of x is equal to f of c, yes, this function is also a continuous function. Similarly, if you look at the fourth problem. So for the fourth problem, let's try to expand and write the function. See, till here you had only polynomial functions or rational functions. Now this is a modulus function. So when you are defining a modulus function, you need to first split and write it. So how to split and write? So this value will be minus of x minus 5 if x is less than 5. So I'll tell you the logic of how to write it. So if you observe the modulus function, so the definition of modulus function is like this. If at all you have f of x is equal to mod x, then f of x can be written as minus x when x is less than 0, 0 when x is equal to 0, and x when x is greater than 0. Now here what is happening is, instead of x within the modulus, let's call this as a variable capital X. Then how can you define it? F of x is equal to, let's say it is capital X. Then f of x can be written as minus of capital X when capital X is less than 0. That is, whatever is the value within the modulus, that should be less than 0. Equal to 0 when capital X is equal to 0. Is capital X when capital X is greater than 5. Now, when I see mod x is nothing, so capital X is nothing but x minus 5. So you can write it as minus of whatever is the value inside. I have written it as minus of the whole value that I have written here, x minus 5. When capital X is less than 0, what is the value of capital X according to the question? X minus 5 is less than 0. So when you solve this inequality, you will get it as x is less than 5. Similarly, it is equal to 0 when capital X is 0. So what is the value of capital X? Capital X is x minus 5. So x minus 5 is 0 means x is equal to 5. Similarly, when you can write it as plus capital X when the value of capital X is greater than 5. So this will be x minus 5 if x is greater than 5. Now if you observe, this is a polynomial function, this is a polynomial function, and 0 is going to be a constant, right? So when you try to observe the continuity for a polynomial function, it is continuous throughout its domain. Now we need to check the continuity of the function only at the point where the function has got divided. If you are able to prove that this is continuous at x is equal to 5, it is clear from the definition of polynomial functions, it is continuous everywhere else. So for that, what we are going to do is, we will take the left limit. So the left limit is going to be limit x tends to 5 minus f of x. So this is limit x tends to 5 minus, what is the value of f of x? We need to take minus of x minus 5. So what is this value going to be? So this can be written as limit h tends to 0 minus of, in the place of x we need to substitute 5 minus h, and minus 5 is already existing. This and this will get cancelled. Minus of minus h is going to be plus h. So limit h tends to 0, h is going to be 0. Similarly, when you take the right limit, what happens is limit x tends to 5 plus f of x. So what is limit x tends to 5 plus f of x? It is going to be limit x tends to 5 plus, what is the f of x we need to consider? We need to take x minus 5 into consideration. Now this will be limit h tends to 0. Now in the place of x we need to write it as 5 plus h, and minus 5 is already existing. This and this will get cancelled. Limit h tends to 0, h is 0. So the left limit is 0, right limit is 0. The function value f of 5 is how much? F of 5 is also 0. Since the left limit is equal to the right limit is equal to the function value, yes, this function is also continuous throughout its domain.